privilege for me. Sir is presently working as an associate professor at Government College of Pharmacy, Aurangabad. He is having more than 24 years of experience in teaching and research. Apart from this, Sir has more than 43 publications on his name and one patent to his credit. Sir has also presented at more than 40 various national and international conferences. Moreover, Sir has guided more than 20 M.Pharm students and one PhD student till now. In his 24 years of journey, Sir has held many important responsibilities. I would like to mention some. He has worked as a resource person in more than 20 conferences and faculty development programs. And Sir has also worked as an expert consultant at various universities like JNTU, SRTM Nanded University, Shivaji University, Nagpur University, and University of Pune. So with this wonderful and impressive introduction, I would like to request Dr. Devkate sir to please guide us on the topic entitled Basic Structure Elucidation, FTIR and NMR. Please, sir.
Thank you very much, madam.
Sir, before proceeding, I just want to make an appeal to all the participants. Please be with us because sir will be taking a little bit more time. Sir has requested, it was the session planned for 1 hour, but considering the task, sir has, I think so, it will take more time, and it is so interesting. Sir will be using the whiteboard too. So I request all the participants to be with us and be patient. Thank you.
Thank you, sir. Thank you, sir. I will not take that much time.
No, you take, sir. So we would love to.
Just I will complete within my given period. Thank you very much, sir. So I am very much thankful to Dr. Shoike sir and his team, Srinath Pharmacy College team, and also the IP Aurangabad brand for arranging such a novel FDP program and giving me the opportunity to deliver the talk. So my topic is somewhat different than whatever topic we have covered up till now. My topic is toward the structural elucidation. So up till now we have done certain theoretical part. So many of the people may not be interested to join or to listen this topic because they'll say that I'm not the chemistry fellow, so why should I come for the structural elucidation? But in all the thesis, okay, so we are using or we are having the NMR spectra, mass spectra, and we are using this IR spectra for this identification of the substances. So one part of my presentation is the interpretation of the IR spectra. So I am talking about the structural elucidation by using the various spectroscopic technique. So can you see my presentation here?
Yes, sir. We can see. Just make it slideshow, sir.
Yeah. Yes,
sir. Yes. Okay, sir.
Yeah. Thank you. So I'm talking about the structural elucidation. Structural elucidation using various spectroscopic technique. In brief, as a basis, I can explain you what is the role of various spectroscopic techniques in the structural elucidation, because not a single technique can be used to know the structure of a compound as a whole. We have to combine all techniques together to just know the structure. So we can start with the UV visible spectroscopy. UV visible spectroscopy, mostly we are using it for the quantitative estimations rather than for the structural elucidation. But some part of the structural elucidation can be done by using UV visible spectroscopy. It will tell you regarding the conjugation systems in your molecule. Then comes the IR that we are talking today, that is for the structure detection of the functional group which are present in your molecule. Then the molecular formula and molecular structure information can be obtained from the mass spectroscopy. NMR spectroscopy, if time permits, we can have some discussion on the NMR also. So NMR spectroscopy is used to, it is of two types, C13 NMR spectroscopy and PMR spectroscopy. So PMR spectroscopy can be used to detect the number of protons, environment of the protons. All about the protons can be obtained by using this PMR spectroscopy. And the C13 NMR spectroscopy tells you regarding the number of carbon and the environment of the carbon. So these are the all spectroscopic technique. All together can give you the information of the structure. But besides this spectroscopy, we also need X-ray spectroscopy for the 3D structural elucidation process, orientations of molecule can be studied by using this X-ray spectroscope. Then advancement of all the spectroscopies are there, like depth. Then we can have the 2D NMR spectroscopies that will give you the more detailed information about the molecule. Out of that, we'll just have discussion today, first with the interaction of this interpretation of the infrared radiations. Okay, so all this spectroscopic working principle is the interaction of this radiations with the molecule and what happened in the molecule. So that depends upon energy content of these radiations. Many of this radiation, depending upon their wavelength, they has the difference in energy, and depending upon their energy content, they interact with the molecule. All of we know that UV visible radiations, they are coming to us this side and having the highest energy content. X-ray, after X-ray means we can start from cosmic rays, gamma rays, then comes the vacuum UV, then comes the UV visible. So they are having the more energies, and as they are having the more energies, they can produce the electronic transactions in molecule, sigma to sigma strike, pi to pi strike. Such type of the transactions are possible, so they require the higher energies. After that, it comes the IR spectroscopy. Energy content is reduced, so they will react differently with the matter, so they will not produce any electronic transaction. But what they can produce, that they can produce the vibrational transaction. There is vibrational changes in the molecule, change in the bond length, change in the bond angle. Okay, so this is all theoretical part. We are not discussing this part here. Then comes the mass spectroscopy, where no interaction with the radiation is there. Still, we are using mass spectroscopy in the process of elucidation because the instrumentation is similar to the spectrophotometer. There is no interaction of electromagnetic radiation. The ions are separated according to their mass to charge ratio. Again, when we go to the next part, that is radio frequency radiations, the energy content is very less. It cannot produce any sort of the vibrational, rotational changes in the molecule.
Sir, sorry to interrupt, but
Yes,
your screen is not moving, sir.
not moving.
Screen is not moving. It is
No,
on
no,
the first slide only.
oh, I am just on the plus side only.
Okay, fine, sir. Sorry.
Okay, okay.
It was question in the chat box that it is not moving, so that's what I thought it was.
No, no, I
Please.
am on the first slide only.
Okay, sir.
Okay, so NMR spectroscopy, the energies we are talking, so it is very less, cannot produce any electronic, vibrational, or rotational changes. So let us talk about the interpretation of the IR spectra now. This presentation is focused on the spectral analysis and interpreting the IR spectra rather than discussion on the theory of IR spectroscopy. Theory of IR spectroscopy, I will not discuss about the bending vibration, stretching vibrations. I will not discuss on the theory, Hooke's law, then simple harmonic motion, how to calculate, or what is the degree of freedom. Okay, so I will not discuss all this part because this all are theoretical. So all of you have studied this part in your previous classes. So we are going to talk about the identification of unknown compound by taking some examples. So we are just talking about the infrared spectroscopy. Infrared spectroscopy is the study of interaction of infrared light with the matter. Okay, so the fundamental measurements obtained in infrared spectroscopy is infrared spectrum. So we are doing the all determinations using this infrared spectrum. So we should know what is infrared spectrum, which is a plot of measured infrared intensity versus wavelength of the light. Means if you see the infrared spectrum on x-axis, you will observe the wavelength, and on y-axis, you will observe the percentage transmission. In UV, you may observe the absorbance on the y-axis. So we are getting a peak in the case of UV spectra, whereas in case of the IR spectra, we are getting certain inverted peaks. Okay, so every functional group will produce a inverted peak that due to the percentage transmission spectra. Okay, when a molecule absorbs infrared radiations, its chemical bonds vibrate. The bond can stretch, contact, and bend. This is why the infrared spectroscopy is called as a vibrational spectroscopy. Many misconceptions and facts are there about the IR spectroscopy. So IR is not generally used to determine whole structure of unknown molecules. It will give you only the very limited information about the molecules, that it will talk about the functional group. And just by knowing the functional group, not a single person can detect the structure. We don't need to analyze every single peak. It's used for identifying certain specific functional group like alcohol and carbonyls. Okay, so what is our method? So we have, our teachers has given the charts, and every time we are looking in the chart and finding the exact peak, we try to identify each and every peak within the spectrum. Okay, so that is called as a hunt and pick. Is not the way to go, trying to match every single peak to one of the numbers in the table. Okay, so a simple technique we will discuss here for the structural elucidation purpose. Before that, where we are using this IR spectroscopy. So that is what is the importance of IR. Okay, the sample or the spectrum is totally unknown. Many substances we are having, unknown substances are there, or even we are having the unknown spectrums. We can use this technique to identify the required examples include forensic sample, environmental waste samples, or new discovered samples where new material has been synthesized. Okay, in research we are using this part. So we are just taking the spectrum and we are comparing the peaks which produced in the spectrum. The second method, or the second point, where the sample or the spectrum is unknown and it needs to characterize or classify. It includes the example commercial applications where new additives or compounds are included, where the various additives can be identified. Okay, the sample, mostly in many cases the sample is generally known, but the existence of specific chemical class needs to be determined. Example includes contaminant analysis, purity. For purity purpose, we are knowing the paracetamol is there, but what are the other impure substances which are present in paracetamol that can be detected? So all official methods has given this IR as a tool for identifying the purity of your bulk drugs. Okay, so now in our pharmaceutics or in many formulation process, we are doing some development of the formulations. We are imbibing the drugs with certain polymers, or we are doing some matrix imbibement, or we are doing certain changes in the molecule for the solubilization purpose. Okay, not whole molecule is changed. Some small modifications we are doing, keeping the molecule intact, and we need to confirm that the molecule is intact. Its structure has not been changed, and information can be obtained by using this IR spectroscopy. So sample is a complex known, and interpretation is required to confirm the material composition or quality, including product quality control also, and confirmation of structure of functionality of newly synthesized compound. What spectra or what part we can see in the spectrum? Okay, so either we are observing the peak intensities. Okay, so all of you know that peak intensities in IR, we are discussing about three types of peak intensities. One is strong peak, some are moderate peak, and some are weak peak. Okay, so this not only depend upon the structure, it also depend upon the concentration. So how much sample, because scarcity is of your sample available for the structural elucidation. Okay, even if your substance is having the intense group, but if you are giving very small sample for analysis, then it will be very difficult to identify the structure. So sufficient quantity of samples should be utilized. So this peak intensity will give you this information. Then origin of peak width, okay, generally depend upon the structure of the molecule. In general, the width of infrared band for solid and liquid sample is determined by number of chemical environment, which is related to the strength of intermolecular interaction. Okay, so we can handle liquid as well as solid samples. Many times we are developing the films in the laboratory, okay, transdermal dosage forms, and how much drug is imbibed in that particular patch of the transdermal system that we want to determine. Okay, so this IR can also be used for that purpose. It can be used for the quantitative estimations also. So this origin of peak width will give you the information how much area is there. Now, for the structural elucidation purpose, origin of group frequencies we are studying. Okay, so what groups are there within that region we are determining. Many functional groups absorb infrared radiation at about the same wave number, regardless of the structure of the rest of the molecule. Okay, so very little effect will be there on the neighboring group, but still ranges are given, not the exact values are given. For example, shear stretching vibrations usually appear between 2800 to 3200 centimeter inwards, and carbonyl C double bond O, which appears between 1600 to 1800 centimeter inwards. This type of infrared bands are called as a group frequencies, and we are using this group frequency for the identification purposes. Before we go for the group frequencies, we should know what are the various regions of the IR spectrum. So by heart, we are doing this from our undergraduate, that there are two regions, fingerprint regions and group frequency region. The fingerprint region lies between 600 to 1450 centimeter inverse. Our teachers are saying the fingerprint region is a very important region. Every substance has a unique identifying characteristic, therefore it is called as a fingerprint region. But actually in practice, this is a very complicated part of your spectrum, and we cannot use only the fingerprint region for the structural elucidation purpose. We are not lying on the fingerprint region, but rather than we are using the group frequency region for identification of the structure, which lies between 1450 to 4000. So just I have developed a small single slide, okay, which will give you the informations of each and every peak which is producing in this group frequency region. So our basic aim is to study this part. Okay, so this spectrum you observe in your front, just it is drawn spectrum. So it is giving all peaks. Not a single substance is there which can show you all these peaks. Okay, so just this is the theoretical thing to remember. Okay, so it is not necessary to remember each and every part of your table. Okay, we can identify all important functional group in a single visual spectrum. Only a part of spectra we are considering is between 1500. You just see this 1500, 3000 centimeter inverse. Okay, so this part only give all information of the structure. Okay, so we are not considering this fingerprint region. Okay, many references are there for fingerprint region. Carburation of peaks can be studied by using this fingerprint region, but mostly we are using this part. Okay, the part which is from 1500 to 3000, and very small part after this 3000, which will help also for the structural elucidation. So we are just plotting two lines. We draw the lines at both the ends, and we are not considering the complex fingerprint regions below 1500. We will only we will only analyze functional group region. Okay, so now we can see this every peak. Okay, step by step we can see the first peak which we can observe is C double bond C. Okay, so it is between 1600 to 1680. Okay, it is a sharp needle like peak we are getting. After this peak, a somewhat broader peak we are getting, that is of the C double bond O, which is lying between 1650 to 1780. Okay, so this is a finger like, some broader peak is observed. Okay, so this gives the information about the C double bond O present in your molecule. Okay, this is followed by a tiny peak. Okay, this you can see this tiny peaks. Okay, like noise of the aromatic ore tubes. So this look like the ticks. Okay, so they look like the ticks. So they are generally present in aromatic. So these are very difficult to identify these aromatic overtones, because many times we may get confused with your noise. Okay, so for that purpose we are having the baseline correction process. Okay, so baseline correction only you will get more knowledge when you practice it. कधी baseline correction करायचं हे depend करतं की which substance is there. Okay, so some basic knowledge you need and some practice or some experience you need to overcome this baseline interference. Okay, so this, if you observe such ticks in your spectra, it might be due to the aromatic substances. Okay, so this is for the identification. The next peak, which is in the center of this part, is for the identification of two functional group. Okay, if you are having C triple bond C, So you may get a peak between 2100 to 2260. Okay, so this peak will be for the C triple bond C type of the functional group. Similarly, at this 2220 to 2260 centimeter inverse, we may have the peak for C triple bond N. Okay, so that is for the nitrile groups. Okay, so this is also for identifying characteristic. After that, for every organic compounds, okay, you will get the one peak. Okay, that is sp3 ch stretch. Okay, for every, because every compound has carbon and hydrogen linkages, and for that we'll get this dog ear like structure. Okay, ham, and that appearing between 2580 2960. Okay, so that is called as the sp3ch stretching. For every compound we will get such sp3ch stretching compounds. Okay, so immediately to the left of this, after 3000, okay, 3000 नंतरचा पण पार्ट थोडासा कन्सिडर करायचा आहे. तुम्ही म्हणताल नाही तर मी म्हटलं तुम्हाला हे 1500 ते 3000, मग आता 3000च्या पुढे कशाला चालले, तर काही पार्ट तिथं सुद्धा आहे महत्वाचं. ओके, सो दिस a sharp peak which we can observe here, that is sp2. Okay, so this is sp2ch stretch. So this sp2ch stretch, we have to confirm this sp2ch stretch by observing one peak at C double bond C. Okay, if you have one peak at C double bond C in the 1600 to 1680, the carburation of the peak is at this level. Okay, so presence of these two peak indicate or confirm the C double bond C alkenes in your compound. Okay, now after this, a sharp needle like peak. So these are not sharp peak. Okay, so these are the weak peak. I have not discussed about what you mean by weak and what you mean by sharp. So this is the intensity of the peak, how much length of the peak you are observing. So this is the short peak. It is in intermediate, it is medium. Now this is the SPCH sharp peak, SPCH stretch. Okay, so this is only available for triple bond containing. Okay, if your compound or your molecule contains C triple bond C attached with the hydrogen, so you'll get a sharp peak at 2700 to 3300 centimeter inverse. So this is again the carburation. So if you are having a peak at these levels and one peak at this level, we can just compare and we can identify or we can confirm that C triple bond C is present. Okay, so this is the simple things. After that, a very common peak which we are observing, that is OH. Okay, which is between 3200 to 3650. A broad peak will get. Okay, so it will a broad peak for the OH. So we can consider presence of OH, or we can just observe the presence of OH in this region. Okay, if you are having acids or amides, then also we will have to be considered. Okay, now see the next slide. A small additions has been shown by the different color. Okay, to just identify. Okay, so you may see, so if you are having the NH stretch, NH bend, okay, so this NH bend of amines and amides, that can be observed here in the range of C double bond O. So this, instead of C double bond O sharp group, we will have a broad bend of this amide group. Okay, NH bend. Okay, so this is the broad group which can be observed in this region. After that, to come to this part, okay, you can see a sharp peak. Okay, so this is the CH peak of aldehydes. So it is very difficult to identify aldehyde peaks as such, just by knowing, because our noise can interfere in determination. Okay, so this aldehyde functional group can be confirmed not using single IR, but it can be also confirmed. We have to combine this IR with NMR data, okay, to come for the particular. So this is CH bend, it is not stretch. Okay, so these are the bending vibrations which is there at 2600 to 2900 centimeter. A sharp peak you will get in this region. And beside this CH bend, we must have a C double bond O. at 1700. Okay, if these two are there, it indicates that aldehydes are present in your molecule. Okay, so small things you can remember. From this we can come to a structural components. Okay, so after this, if the amines are present, NH, okay, NH bending vibrations, you may get the singlet or doublet or triplet. Okay, so this is splitted part, and it is broader, and in the region of the 3000, after the region of this more than 3000. Okay, so this is presence of amino group in your molecule that can be indicated by doublet triplets in this region. Okay, so a peak for aldehyde CH bed is also observed near 2600 to 2900 centimeter, which is supported by C double bond O stretch at 1700 centimeter. Okay, that can be confirmed by NMR spectroscopy. Now, I would memorize them how all of them are looking. Okay, just this single spectrum will give you information of all basic infrared groups which is available, and apply for the structural elucidation purposes. Okay, so we'll just have certain examples of the structural elucidation. Just see this. Now, I can't be able to hide this. Just I want to show the spectrum and then how we come to the conclusion that I had to show. Now see this one spectrum is in front of us. Now what we have to do, just draw the line from 1500 to 3000. Okay, and draw the baseline. Now the instruments are available which can draw the baselines. We can go for the baseline correction automatically. We have to set the limit and they will show the baseline corrections. Okay, so now you just see this spectrum. We don't have the C double bond C peak here. Okay, near the 1600. We don't have C double bond O peak here at 1700. We don't have C triple bond C or C triple bond N at 2200. Okay, so what we have, only one sp3. Sp3 will be there common in all compounds because CH will be there and sp3 will be there in all compounds. After that, we are getting a OH broad peak. It indicates that it is alcohol. Just blindly we can say that our compound is alcohol. We will just discuss this with certain examples also later on. Now, one more example, or one more compound we can say alkenes. Okay, alkenes, ENE, double bond. So if you see the structure or if you see the spectrum, okay, so again I have drawn the line from 1500 to 3000. Okay, by using mouse, it was very difficult to draw this line. So I have already drawn it slowly. Online I can do it properly. So I had done it already before I prepare this presentation. Now see the baseline I had taken here. Okay, many times you may think that why not to take the baseline here. So this might be the C double bond C, C triple bond C. Okay, in the center 2100 or 2200. Then why I had taken this baseline here? Because only I want to talk about the alkenes. I don't want to talk about the other compounds. So see here at the 1600, I have this peak of C double bond C. sp3 will be common as CH will be present, and one more carburation of the peak will be there, that is sp2. Okay, after 3000 we are having a sharp peak here of this sp2, and this the presence of this peak indicate the presence of alkene in your structure. Okay, so this is the simple way how the alkenes are identified. Now see this complex spectra. Okay, again I have drawn a line from 1500 and one line at 3000. Okay, then I am just checking all the peaks which are present in this region. The first peak I can observe is C double bond C at 1600. Okay, so this C double bond C might be there. Then small aromatic overtones I have observed here. These aromatic overtones giving the information about the presence of aromatic group. Okay, so which can be confirmed by checking the peaks at this position 600. Okay, so fingerprint region also we have to check for these aromatic groups. As my discussion was not involving determination with the fingerprint region, I will only talk about the functional group region. Okay, so I am just observing this overtones. Again, sp3 will be common as C stretch. After that, sp2 I will observe because C double bond C is there. So a small peak will be there of this sp2. There is no presence of hydroxyl group. There is no presence of the C double bond O group. There is no presence of C triple bond C. Okay. There is no presence of the aldehyde bending vibrations. No amides. So my structure is alkyl groups. Again, alkene, YNA, triple bond. Okay. So again, a spectrum was in front of me. Now I had again drawn the line from 1500 to 3000. And I'm just observing. Okay, so this baseline might be from this part. We can draw the baseline here and see at the exactly in the center 2200. Okay, so we are getting, see, this is 2100 and 200 near 2200. We are having one peak of C triple bond C. This sp3 will be common. After that, a sharp peak I will get for the sp hybridization, CH stretch. Okay, this sp hybridization I will get. This is confirming the structure of C triple bond C, alkene groups. So in this way, just by observing and drawing the lines, we can confirm the structure of the compound. Okay, so this is about the alkene group which is present in your spectrum. Now, after this, we will go for some examples. Just wait. Okay, now see the next spectra. So whenever we see the spectra, directly we just check the peaks. What is the problem? Simple problem is there. Which molecule is responsible for the falling spectra? And as per our discussion, directly we'll see the spectra. We'll draw the line in 1500 and 3000 and start detecting the structure of molecule. No, that is not the way. Don't jump to directly the spectral region. You just first check the molecule. Why? Because molecules are in front of you. Okay, omit the possibilities of the molecules by observing the functional group. Observe the molecule first. Don't observe the spectrals. Okay, first job is to observe the molecule. You're identifying the characteristic of the molecule. Characteristic of molecule that indicated by the presence of functional group. Okay, so now see this first structure. There is a presence of C double bond C. Okay, so we should have a peak at 1600. Okay, see this 1600. Okay, so this is 1500. So this is 1600. So we don't have the peak at the 1600. Ultimately, this is not the possibility. See the other structures also. Here also there is CH double bond CH. Again, there is no peak at the 1600. Both the possibilities are vanished. Okay, so we can go next to the next part. Okay, here. So in this, what functional group we can observe? There is a presence of OH. Okay, we can see this presence of OH. And we also have a broad peak at 3500 for OH. Means the possibility of your structure is this. Okay, so you may have this functional group present in this structure may be there. Now you check the remaining structure. Here also we have OH. Okay, so this we can consider as we have this OH. Now in this structure there is ethereal linkage. Now from the structure it is confirmed that our substance contain OH. So we cannot go for OH here. Now we cannot omit the possibility of OH. And here in this structure there is no OH. So just we will omit this structure also. 1, 2, 3 structures has been omitted. Now these two structures are there which is having the OH. Okay, now again see this both structure. Besides OH, this structure will also contain double bond O group. Okay, double bond O means that is near 1700. Okay, see here. You go for this 1700 region, there is no peak. Okay, again this possibility is also completed. So just this is the table. You just go through the table. same thing what we had discussed in the spectrum, it is written on this table. Okay, so this all possibilities has been vanished, and only this structure has been confirmed. Okay, we are able to confirm this structure by using the IR spectroscopy. Okay, this is very simple. So don't rush toward the spectra first. You try to see whatever possibilities or whatever structural components as given, whatever functional groups are present. We will take one more example for this structural elucidation. Okay, see this second structural elucidation. Which molecule is responsible for the falling IR spectra? Okay, so now you come one by one. We will discuss in the chat. Can we discuss it on the chat? Okay, so what you are observing in the spectra? Hello friends, please report your observation in chat, or you can unmute and you can talk. Yes, one is observing the C triple bond CH, but go for the first structure first. From structure 1 we can start. Yes, CH.
OH is not there in the group.
OH is not there. Yeah, so first structure contain OH as your one group. Then so the possibility of the first structure as OH is not there. Okay, the possibility of first structure and possibility of third structure has been vanished. Okay, now this is presence of CH triple bond CH. Okay, so we may get the peak in the range of what? So this is sp3. Okay, this is sp3. It is correct. For every group, sp3 will be there. Okay, for CH triple bond CH, we should get a peak at 2200 here. Okay, 2200, 2100 to 2200. We don't have this peak here also. So this possibility is not. So this is also wrong. This is also wrong as OH is not there. Now you see this 2. Okay, so in both cases there is C double bond O, and here also C double bond O. So you should get a peak at 1700. See this 1600, 1700. We are having a sharp peak, and this present shows the indication that C double bond O is present in your molecule. Okay, see this C double bond O here, C double bond O here. Now, which out of these two, how you will confirm the structure? Yes. दोघांपैकी कोणतं आहे तर तुम्ही कसं सांगणार? Anyone? You can unmute yourself or you can draw it. How to distinguish two structures? See here. Yes. This is very correct. See, this is to be drawn by someone that this is the CH band. Okay, we are appearing this CH band at this point. Okay, SP. This is SP3. After SP3, there is a presence of CH band. Okay, that is of aldehydes. This is the characteristic of the aldehyde functional group. So we can just check that this is the possibility. Okay, because we are having the aldehyde band peak at this level. Okay, so just by doing this, we can identify the exact structure. So this is not the possibility. See this. Okay, so this is the aldehyde which we are getting here, and all these possibilities has been vanished. In this way, we can have the simple structural elucidation process. Organizer may have. Hello. शेळके सर.
Yes sir.
अजून काही टाइम आहे का?
Yes sir. आपल्याकडे टाइम आहे सर. आम्हाला नाही ऐकायचं सर आम्हाला.
नाही तेच म्हणत होतो मी. नाहीतर जर टाइम जर नसेल तर
नाही सर. You take your own time sir. We are with you.
बरं, we will omit for the NMR because already it is 12:30. Okay, we will only go for the IR. Okay, so see here one more slide I have prepared. जे काय आता मी तुम्हाला एक सिंगल स्लाइड मध्ये सांगितलं होतं, तर स्टेप बाय स्टेप कन्फर्मेशन ऑफ स्ट्रक्चर we can discuss on this slide. See, this is a carbonyl group. Okay, carbonyl group present. First step is to see the carbonyl group. Whenever we observe, we should see 1700 the groups between 1660 to 1820. If carbonyl groups are there, what are the possibilities for carbonyl groups? We have to check the possibilities of carbonyl group. Carbonyl group may be present in acids, it may be present in amide, it may be present in esters, anhydrides, aldehydes, or ketones. Okay, so this can be confirmed if acids are there. With your C double bond O group, we will have one peak for OH. There is presence of OH. Okay, so that presence of OH between 2400 to 3000 means after 3000 we should get a broad peak for the OH. Okay, so this is indicating the presence of acid. Then if amides are there, in case of amides, there will be a doublet or triplet present. Okay, it will be not sharp as the OH. Okay, so it is a somewhat broad peak will be there after 3000 centimeter inverse. If there is esters, okay, so esters can be confirmed by going towards the fingerprint region rather than the functional group region. Okay, for this OH, we have to see the bending vibrations in 1000 to 1300 centimeter inverse. Okay, if aldehydes are present, again, as we have seen aldehyde example, that there should be a bending vibrations of NH, CH stretch, CH bend at nearer to the 2700, 2900. Okay, aldehydes for this. Then in ketones, if we do not observe anything like this, okay, so it will be the ketone. Only you will get C double bond O in case of the ketone. If carbonyl groups are absent, okay, if C double bond O is absent, then we can go for the checking next possibility of the structural component, that either there may be the hydroxyl group. So this hydroxyl group can be checked by observing a broad peak between 3300 to 3400. Okay, confirm this with the CO bend in fingerprint region. We can also check it for the fingerprint region. So in amines, okay, so if in amines there will be the singlet, doublet. Okay, so you just see this single chart. Okay, so this single chart will give you all the information. If the amines are there, so you may get the peak here. Okay, with sites. If you don't have this C double bond. Okay, for ethereal linkage only can be checked into the fingerprint region. Okay, it cannot be changed into the functional group region. Okay, so then double bonds of the aromatic rings. If aromatic structures are there, we will get the overtones at the this level. Okay, so see these overtones, we can go for the aromatic, and with these overtones, we should have this sp2 peaks. This presence of these two peaks will confirm the aromatic structure. Okay, then come the vinyl structure. Okay, so for vinyl, we should get the more than C triple bond C. Okay, so see this, a sharp peak should be there after 3000. Okay, so this is for the presence of vinyl. Carburation of the peak, C triple bond C at this 2200 and 2100 to 2200, and one peak, a sharp peak at the after 3000. Okay, so this is the vinyl group. So then again we can confirm the triple bonds like C triple bond N and C triple bond C between this range. Okay, so again I given it in the here, C triple bond C and triple bond N. Just by understanding a single spectra, we means every peak will not be there in a single spectra, but this structure you can remember and you can identify any functional group in your molecule. So where you will require this. So now there is a time to write the thesis. Many students are working on writing the thesis and they are coming towards you, sir, this is my spectrum, let me know what are the functional group present. Okay, so what you can do, you have to just note down this important functional group in the table. You have to give the ranges, what you observed, and you have to confirm this with the structure. Okay, so this will, there should be the discussion also that my C double bond O C confirms with the original C double bond O C present in the molecule. It indicates that same substance I am using for the development of the formulations, or my product is containing this, indicating the presence of the particular substances. Okay, so this presentation or this discussion should be written in your thesis, even if it is SUTIX for the confirmation of your, or for authentication of your drug, or if it is chemistry, if you're synthesizing new chemical entity or modifying it, then you have to write the structural elucidation in your thesis. Okay, so I think it is 12:30. Should I go for the NMR? Okay, sir.
Yes, sir. Yes, sir. Yes, sir.
Just I have to stop this now. How can I stop this?
So stop sharing, and the top of the screen will be there. It will be there. Stop sharing. Okay, sir. Now you can again share your
Second
next slide.
presentation. Yes, sir.
Yes, sir. Is it okay with everybody? You can the message in chat box also. So accordingly, we can continue.
Okay.
Yes, sir. Participants are feasible. No issue, sir. We can continue, sir.
We can continue. I will just.
Yes, sir. Yes. Yes, yes, yes.
I will.
So again, you need to do share screening. Share screen.
Yeah, just wait. I'm opening this. कुठे गेला ते शेअरिंगचं?
खाली आहे सर, शेअर स्क्रीन हिरव्या कलरचं दिसेल बघा तुम्ही खाली बॉटमला शेअर स्क्रीन म्हणून येईल खाली.
रिटर्न टू मीटिंग मध्ये जायचं का?
येस येस येस.
हा, शेअर स्क्रीन आला.
हा सर, स्लाइड शेअर करायचं. Okay, sir. Fine, sir. Yes, yes, yes.
So just we'll have the discussion on the NMR spectroscopy. Okay, so up till now we have studied only the IR part. Now we'll discuss with the NMR spectroscopy, how NMR can be used for the structural elucidation purpose. Okay, before we go for NMR spectroscopy, small things I want to just discuss regarding the basis of the NMR spectroscopy. As the radiation does not contain too much energy that can produce the vibrational, rotational, or electronic changes in molecule. So what is there in NMR spectroscopy? There is only change into the magnetic properties. Okay, see the name, nuclear magnetic resonance. In all spectroscopy, we observe the resonance. So what do you mean by resonance? Resonance means something from ground state goes into the excited state. It will not remain long time in excited state. It will try to come back to the ground state by remitting back the energy, either in terms of the radiations or in terms of the heat. This is the fundamental principles of all spectroscopic technique. Okay, so resonance is involved. Resonance in case of UV electronic transactions are there. So there is also something from sigma to going for the sigma strike, that is excited state. Pi to pi strike, that is the excited state. In vibration also, there is something going from fundamental vibration to overtone vibrations, from one level of vibration to the other level of vibration. So what is there in the NMR spectroscope? Okay, so there is also absorption of this NMR radiations, and the nucleus, which is there, the spinning or the magnetic properties of nucleus, they are in the ground state, they will go to the excited state. Okay, and coming back to the ground state. Okay, so that is the basis of NMR spectroscopy. Resonance will be involved. Only the resonance is not there in the mass spectroscopy, because it is not the interaction of the electromagnetic radiation. In every spectroscopy, resonance will be there. Okay, so before we go for this mass spectroscopic problems, we should first know the ring rule. Okay, that is, if you have the molecular formula, and from the molecular formula, how we can calculate the hydrogen ion deficiency, IHD. Some book says it as a HID, some book says it as a ISD. Okay, so one ISD is responsible for two hydrogen, means one double bond or two hydrogen. If there is a deficiency of two hydrogens, it will count for one HID. So we should know how to calculate this HID. I think all of you are knowing this, but as a part of this presentation, I will just summarize it fast. Okay, so there is a formula, 2C plus 2 minus H, that is number of hydrogen, including halogen. Okay, 2C, that is number of carbon multiplied by 2, C2n plus 2. माझा एक सिंपल फॉर्म्युला होता, C2n plus 2 minus number of hydrogen including halogen. ओके, नंबर ऑफ हायड्रोजन इन्क्लुडिंग हॅलोजन, म्हणजे हॅलोजन सुद्धा जितके असतील तेवढे सुद्धा आपल्याला सबस्ट्रॅक्ट करायचे, प्लस नंबर ऑफ नायट्रोजन. ओके, होल ब्रॅकेट प्लस नंबर ऑफ नायट्रोजन divided by 2. So it will give you the how many double bonds or rings are present in molecule, that can be calculated by using this formula. We'll just have some examples of this. We'll not go in how this formula is coming. What is the HID for each of the following molecules? See this, C6H10. Okay, so you just chart me what is the HID values. Okay, what is our formula? C2n minus number of hydrogen including halogen divided by 2. Okay, see this. First is your C6H10, number of carbon 6, 6 multiplied by 2, that is 12, minus hydrogen 10, that is 2 divided by 2. किती येईल? C6H10. Similarly, you go for C6H6, then you go for C4H8. चार्ट मध्ये टाका. Are you able to calculate fast? एक part of presentation आहे. See the calculated values I will write. C2n plus 2, साई दुने 12 plus 2 14 minus 10, that is 4 divided by 2, therefore 2. Okay, so in this way we can calculate the HID. So in NMR structural elucidation process, we first need to calculate the HID. Okay, so HID calculations are there. In some cases, if the molecular formula is not given, okay, if molecular formula is not given, only the molecular weight is given. In that case, we can determine this molecular formula by using rule of 13. Rule of 13 can be used to find out the possible molecular formula. So I will not discuss this rule of 13 here. Again, this is the example for calculating HID. We will omit this because it is taking time. Now see the first NMR problem. We have this formula C3H3Cl5. And we have these peaks. Only these two peaks we are observing. One is your triplet, one is your doublet, and they are appearing at the delta value of 4.52 and delta value of 6.02. Okay, and see this part. Okay, so this part is a ratio. In some spectra, this ratio is given in terms of the squares. Okay, where we can calculate. It's directly दिला मी 1 hydrogen, 2 hydrogen. Okay, it might be given as a 3 squares and 6 squares. Okay, then we have to find out the ratio as 1:2, that is of the hydrogen. So now if this structure is, if this formula is given and it was asked to calculate the structure or to determine the structure, so what we can do? Okay, so we have to, first step is to calculate the HID. Okay, so what will be the HID of this structure? Please comment, anyone. हे comment कशा पाहिजे हो सर? मी तुम्हाला तर म्हणतो कमेंट, पण मला दिसतच नाही कमेंट.
सर सगळे कमेंट करतायत चॅट बॉक्स मध्ये, खाली चॅट आहे ना, तर तिथे कमेंट करतायत सर सगळे.
ते कुठे बघायचं म्हणजे चॅट बॉक्स?
खाली चॅट म्हणून आहे सर, बॉटम लाईनला बघा सर तिथं. आता पहिले पण उत्तर दिले तुमच्या, तुम्ही जे विचारले ना 111 इथं आहेत बघा खाली. तिथं चॅट
बाजूला आहे सर.
खाली शेअर स्क्रीन असते ना सर, त्याच्या बाजूला एक चॅट म्हणून येतं एक. मोर मध्ये वरती सर, वरती वर
मोर मध्ये बरोबर 102 चॅट येते.
हो हो
बरोबर. हा HID is 0. Yes. दळवी, संपदा दळवी. She's saying HID is 0. बरोबर. C3. Okay, 3 2s are 6 plus 2 8 minus number of hydrogen, that is 3, plus number of halogen, that is 5. So that is 8 minus 8 divided by 2, 0. So first step is to just find out the HID. Okay, HID is 0. Then we have to write, if the HID is 0, there is no double bond or no ring. Now you go for this ratio. Okay, so ratio indicate 1H. Okay, so it is a CH, and 2H, that is CH2. Okay, so this ratio. Then you go for this splitting pattern. The first step is to find out the ratio. From the ratio, we can conclude that this is CH and this is CH2. Then the third stage is to go for the splitting pattern. You observe the splitting pattern. First signal is splitted into the triplet. So we have the formula N plus 1. N is the number of proton present onto the neighboring carbon plus 1. Okay, so that is the first step. It will give you the indication that how many protons are present onto the neighboring carbon. So triplicate indicates that my neighboring carbon will have 2 hydrogens. Okay, so this CH2, pen okay, so this
फॉर्म आणलाय मी. त्याचं काय फॉर्म फीसचं म्हणलं किती फीस होती त्याची?
So the first triplet, okay, the first triplet says that my neighboring carbon
आणि ऍप्लिकेशन पाठव सांगितले.
My neighboring carbon will have the 2 hydrogens. Okay, because this is the first triplet saying that my neighboring carbon has the 2 hydrogens. Okay, so this CH2 which is there, we have determined here, is confirmed. Then the second peak says the doublet. So what this doublet indicate, that my neighboring carbon will have the 1 hydrogen plus N plus 1 rule is there. N is the number of hydrogen present onto the neighboring equivalent carbon plus 1. Okay, so this doublet indicate the presence of this CH. So these 2 CH and CH2 has been confirmed by this splitting pattern. So now we have what component, that we have 1 CH, 1 CH2 out of this. Okay, so just we combine all the structural component together. Okay, so just we combine to get the various structures. Okay, so we have 3 carbons, so we'll just write 3 carbon here. HID is 0, so we'll write 1 2 3 carbons. Then we'll have 1 carbon as a CH2, another carbon as a CH, and we'll attach all the chlorines to this structure. Okay, so where to attach the chlorine? Till it satisfies the valency of carbon. Okay, so now see the structure and see the splitting pattern. Now this CH, okay, so this CH, the neighboring carbon contain 2 hydrogen, will produce CH3, and this CH2, the hydrogen of this will produce doublet because neighboring carbon will contain the 1 hydrogen. Now we have to confirm this structure by allotting the delta values. See, these are the delta values. You can observe the delta values. Delta values are generally divided from 0 to 10. Okay, so this 0 to 10 values are characteristic. Nearer to the 0 is called as an upfield, and nearer to the 10 is called as a downfield. Okay, upfield appears for the shielded protons. The shielded protons means the protons which is not shared by the electronegative groups, which are not surrounded by the electronegative group, appears at the upfield, and the protons which are surrounded by the electronegative group will appear at the downfield. Okay, So now this chlorine is electronegative group. जर नुसता CH3 किंवा CH असतात, it should be appear at nearer to 1. Okay, if it is CH3, it should appear at 1. But now this CH, see, it is appearing 6.02 because directly it is attached to the chlorine. Okay, so this doublet producing are attached directly to the chlorine. This it is attached to the carbon, which is again attached to the chlorine. So these electronegative groups, they produce the de-shielding effect. Okay, and this can be confirmed. We just assign this 1 and 2 values. So this is your triplet producing. This is 1 peak and this is 2 peak. In this way, we can elucidate the structure by using this NMR data. We will have the second examples for this again. You see, again, these examples are interesting. I think you may have solved this example at your undergraduate or graduate level, but still try to do this. The first step, as per our discussion, is determination of the HID. So what will be the HID for this structure? Chart. Again, same. HID will be 0. Yes, correct. HID is 0. Okay. Now the second step, check the ratio. Okay, CH3. This is CH3 and this is CH2. Okay, see the ratio and decide these two components. One is CH3, one is 2. Now you go for the splitting pattern. Okay, every splitting pattern says the singlet. Singlet means N plus 1. N is 0. Okay, neighboring carbon contain 0 hydrogen plus 1. So therefore it produces the singlet. Okay, so what this first singlet says, my neighboring carbon is without any hydrogen. So it is a simple C. This also says that my neighboring carbon is without hydrogen. So now we got 1, 2, and 3 carbons. Okay, we got 5 hydrogens. Now you assemble all these to get a particular structure. So when you are assembling, you have to arrange all the structures, okay, possible, and other structures also. Then we have to omit the possibilities. जे नाही आहेत ते बाजूला काढायचं, जे आलेत त्यांना टिक करा, and you have to confirm the structure. Okay, now see, I have written this all carbon, carbon, carbon here. Then I have put this one CH3 here, then one CH2 here, and attach all chlorines. Okay, so see here, my both the peaks will produce singlet. This CH3 neighboring carbon without hydrogen, so it will produce singlet. This CH2 will also produce singlet. Okay, so I have 2 singlets here. The singlet can be confirmed by observing this structure. Okay, so now how to confirm the singlet? A singlet ह्याचाच हे कशावरून confirm करायचं? So this can be confirmed by alerting this or by checking this delta values. Okay, see the first delta value is 2.20 and the second delta value is at 4.02. Okay, 4.02 is somewhat more de-shielded as compared to 2.20. Okay, so see here, 4.20. This chlorine is directly attached to this CH2 group. Okay, so it is producing more de-shielding effect to this chlorine due to this chlorine. This CH3 is attached to the carbon which is attached to the electronegative group. याचा electronegative group याच्यापासून खूप दूर आहे. Okay, so they are appearing somewhat towards the upper side of your spectrum. So they are shielded protons. Okay, so these protons appears at the upfield and these protons appears at the downfield, and then we have to assign this as a 1 and 2. So I will just write 1 here and 2 here. In this way we can identify the structure. Okay, one more problem we can take. Now this is the interesting problem. Anyone, you can draw the structure here also. Okay, first you calculate the HID value. What will be the HID value? इथं डायरेक्ट लिहिलं तरी चालेल ना स्क्रीन वरती तुमच्याकडच्या पेननी बाजूच्या. What will be the HID value? C4H9Br. 4 2s are 8 plus 2 10 minus 9 plus 1 10. So HID value is 0. Yes. Then see the splitting pattern, the ratio. Okay, the second step is to see the ratio. The first ratio is 6 hydrogen. 6 hydrogen cannot sit on one carbon. Okay, so there might be the chances that these carbons, these hydrogens are equivalent hydrogen. So there may be the two CH3 groups. Okay, so this will give you first information that I have two CH3 groups which is in the same environment. Okay, then this one hydrogen will say that I am CH. Okay, हे splitting pattern म्हणतात स्वतःबद्दल, हे रेशो म्हणतात स्वतःबद्दल, आणि स्प्लिटिंग पॅटर्न विल टेल यू अबाउट द नेबर. ओके, माझ्या शेजारी काय हे सांगणारे स्प्लिटिंग पॅटर्न, आणि मी काय हे सांगणारे तुमचा हा रेशो. Okay, so this ratio says that I am CH3 CH3, this ratio says that I am CH, and this ratio says that I am CH2. Okay, so this is the second step. Now third step, see the splitting pattern. Splitting pattern says doublet, means my neighbor contain one hydrogen. This says that my neighbor contain one hydrogen, so one hydrogen might be this. Okay, means my neighbor is CH, it is confirmed. Then this is multiplet. Multiplet is more than 5. If more than 5 hydrogens are there nearby, it is giving the multiplet. So if multiplet and singlets are there, it will be somewhat difficult to judge the neighbor. Okay, then comes the doublet. Doublet, again it says that my neighbor is CH. Okay, now we have 1 2 1 2 3 4, means all 4 hydrogens we got, all 9 hydrogens we got, all 4 carbons we got. 6 7 8 9 hydrogen मिळाले. Only we have to place the bromine. So you arrange these all 4 carbons. Okay, so we have 2 carbons with the same environment, so we'll just arrange CH3 here, which is attached to the carbon, which is attached to the CH2, and then Br. Okay, this is here only I can draw the known structure or the correct structure, but we also should go for the other nonsense structures also, and then omit their possibilities. Okay, by I can just write CH2 here, CH2, then again Br I can join here. Okay, I can write this CH3 afterward, and then I can say my peak is not multiplet. Okay, so that can be identified. So see here how I am getting peak. This CH3, it attached to the carbon with one hydrogen. Okay, so this CH3 will give the doublet. As this CH3 is in the same environment, it will also give the doublet, and these two doublet will overlap on each other, and the height of peak will be more or equals to the 6th hydrogen. Okay, so this, therefore it is the ratio is of 6 hydrogen. Then comes the CH2. Okay, so this CH, the center one, it is having this CH attached near carbon, this CH attached to this carbon, and this CH2 attached to this carbon. Means there are 3 plus 3, 6 plus 2, 8 hydrogen plus 1. Okay, so that will produce the 9, no, 9 8. Okay, nonate. So this nonate will be considered as a multiplet. Therefore, this CH is giving the multiplet. Now this CH2 is again having one carbon which is attached to the hydrogen, and it is giving a doublet. Okay, so we are having 2 doublet, we are having 1 multiplet. So this structure confirms. Now you can confirm this structure by assigning these delta values. Okay, so this delta value can be assigned there. So now see the delta values. One is one doublet is at 1.02, whereas the other doublet is at 3.30. Okay, see this bromine, it is attached to this CH2. Okay, so this bromine is electron withdrawing group, causes it towards the downfield. Okay, so this third doublet might be this due to this CH2. Okay, and the first doublet might be due to this CH3. So we can assign this as 1 1, then this is the 2, and this is the 3. In this way we can elucidate the structure of compound using this NMR spectroscopy. One more structure we can go. Now see C10H14 having first singlet, second singlet at the delta value of 1.30 and delta value of 7.320. the first is equivalent to 9 hydrogen and the second is equivalent to 5 hydrogen. First, you calculate the HID. Okay, you calculate the HID, how much it is? 8.
Four.
How much HID is there?
It is 4.
8 lile konitari. It is 4. Okay, yes, it is 4. The HID is 4. How? 10 2s are 20 plus 2, 22 minus 14. Okay, 8 divided by 2, that is 4. The 4 HID, see, if you are getting the 4 HID, 3 things are there. If you are getting 4 HID, if we are getting one signal with singlet, which is lying between 7.2, okay, 7 to 7.5, if a signal is there, okay, and equals to 5 hydrogen. Okay, so this is all will make one identification that aromatic ring is there. Okay, directly it will solve the problem of all HID, because one aromatic ring, a pen कसं चालू होत नाही व्हायचं? बॉल पेन घेतलं, हे पेन चालू झाला असता ना, मला इथे स्ट्रक्चर काढता आलं असतं. पेनच चालू होत नाही. ओके, जाऊ ठीक. Okay, so this 5 hydrogen, 7.2 delta value and singlet, this is all indication, and HID4, this is all the indication that aromatic group is present in your molecule. Okay, directly 10 पैकी 6 चा हिशोब मिटला. Okay, so just now remaining 4. Again, see here, 9 hydrogen cannot be sitting on one carbon. So all these are the 9 equivalent protons. So there may be CH3, CH3, CH3. Okay, so all CH3 will be here, 3 CH3s and 1 benzene ring. And as these are all giving the singlet, okay, the splitting pattern says that my neighboring carbon contain no hydrogen. Okay, so there is one carbon without hydrogen. Okay, so we have this structural component. So we'll try to combine all these structural component to get one structure. As we are having the benzene ring, HID4, we are having the benzene ring. So we'll just add the component to get the particular structure. Now see the peaks which are produced. So this CH3, 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 the neighboring carbon contain no hydrogen. So N+1 rule, it will split into the singlet. And definitely this aromatic ring, that is also giving the singlet. So this is only possible with the 1D NMR spectroscopy. I am not talking about the 2D NMR spectroscopy. In 2D NMR spectroscopy, benzene ring will give the 2 doublets. Okay, so that is different one. Okay, so just we'll have the basic version. So this is the 1D NMR spectroscopy where we'll consider it as a singlet. Okay, so this benzene ring is giving the singlet. So all 5 hydrogens, 1, 2, 3, 4, 5 are there on the benzene, and this all 9 hydrogens are there on this CH3. Okay, so now we have to assign la काय का दोनच peak आहेत. Okay, one is 1.30. Write this peak number 1, 1, 1 here, and write this peak 2 here. So the structure confirms. We'll have just one more examples. Yes, sir. Okay. First step, again, go for calculating HID. It was also C10H14. This is also C10H14. Yes, correct. The HID is 4. Now see the splitting pattern. The splitting pattern says it is 6 hydrogen. 6 hydrogen cannot sit on the single carbon. So all are in the same environment. So there may be CH3, CH3 here. Okay. This is the multiplet producing hydrogen. So this is CH. This is CH2. One benzene ring is there because our HID is 4. Presence of 4 HID. Okay. There is presence of a singlet and 7.12 peak with the 5 equivalent protons. This indicates that there is presence of aromatic ring. Okay. So this ratio we are consider. Now we'll go towards this splitting pattern. First peak is your doublet. Doublet indicates that my neighbor contain the 1 hydrogen. So this CH is confirmed here. My neighbor is CH. One multiplet that my neighbor contain the many hydrogen. Then this is again the doublet, my neighbor contain the one hydrogen, and this is the singlet, that is of the aromatic. Okay, so we have all these components together. Now we assign all these components. OH 9 OH 9. Okay, so benzene ring. We will assign all these components to get a particular structure. इथं directly उत्तर देतोय मी तुम्हाला. It is CH2, CH, CH3, CH3. Okay, so we can have the other structures also. हा CH3 इथं सुद्धा आपण ऍड करू शकलो असतो. एक हायड्रोजन याच्यावरचा काढायचा, याला CH2 करायचा, याला CH, आणि याच्यावरचा हे दोन्ही CH3 इथं शिफ्ट केल्यास. Okay, we can shift this CH3. Okay, so different structure you can think, but I am just short of the time. I am at the exact structure. Okay, now see the splitting pattern. This CH3 is in the same environment. Okay, so and the neighboring carbon contain one hydrogen, so they will produce the doublet. So these two doublets will overlap to each other, and the height of the peak will be equals to the 6 proton. So these are in the same environment. Now this CH, okay, neighboring carbon contain 3 plus 3 plus 2, 8 plus 1, 9. It will produce nonate. Okay, so nonate, that is a multiplet. So this hydrogen is also confirmed. Now this CH2, it is producing doublet. This CH2, the hydrogen, the carbon which is attached to this contain only one hydrogen. Plus n plus 1 rule indicates that there is presence of doublet here. Okay, so now you assign the values. Peak assign. Okay, कशाला कोणता peak म्हणायचा, कारण याच्यात दोन डबलेट आहेत. दोन मल्टीप्लेट आपण कन्सिडर करू शकतो. This is multiplet and this is aromatic. So how to assign these two doublets? One doublet is appearing at 0.88, whereas the other doublet is appearing at 2.45. Okay, how we can distinguish this? Sir, 1 वाजायला लागला. Okay, see these two doublets. This CH3, it is attached to the carbon, which is attached to the carbon, which is attached to the aromatic ring. Means these CH3s are more shielded protons. Okay, these protons, CH3 protons, are more shielded, so they will appear at the upfield, that is 0.88. Whereas this other doublets, okay, so the protons are appearing at the downfield due to this aromatic structure. Okay, due to this aromatic structure, they are going towards the downfield. So just we can write 1 here, then 2 here, 3 here, and 4 here. In this way, we can elucidate the structure. एक हजार इंटरेस्टिंग आहे, हा शेवटचा करू. ओके, नंतर just after this we can stop. Quintet, triplet, singlet. Okay, so just yes, HID is 5. तिथं दिसतं तुम्हाला आपोआपच आलं. पुढे yes, correct. HID is 5. The first splitting pattern show, the first ratio shows it is CH2. The second ratio shows it is CH2. Anyone can draw the structure? HID is 5. 5 HID indicates that there may be one aromatic ring and one double bond. There may be one aromatic ring with another ring. There may be 5 double bonds. But as there is a singlet which is appearing at 7.17, it indicates that aromatic substances are there. Okay, now go to the splitting pattern. First step, HID calculation. Second step, finding the ratios. Third step, go for the splitting pattern. First splitting pattern is quintet. Quintet means 4. Okay, so 1 4 will be there. If the neighboring carbon content, for it is quintet means 5. If the neighboring carbon content 4 hydrogen, it will produce quintet, 4 plus 1. Okay, the second is triplet. The neighboring carbon contain 2 hydrogen, and this is the singlet, that is for the aromatic. Anyone can draw the structure. What is the possible structure here? Or just I will keep it as a suspense for you. Yes, benzene मध्ये डबल डबल बॉन्ड कशाला येतील? हे गोल केलं म्हणजे हा डबल बॉन्ड नाहीच आहे. Any more? One more chance. Anyone can draw this structure here, or you just note down this. I will keep the answer in suspense. CH. पुढे CH, CH3, CH3. CH3, CH3. मग पाचवी HID कुठे गेली? We are having 5 HIDs. ते स्ट्रक्चर नाही आहे. Okay, friends, I think I should stop here because already it is 1 o'clock. I'm not giving you the exact answer of this structural installation. So you can comment or you can draw this structure or you can tell me the structure. Okay. One hint I want to give you, see the data given. Okay. The last peak, it is equivalent to 4 hydrogen. It is not equivalent to 5 hydrogen, indicating that it is a di-substituted benzene ring. It is a di-substituted benzene ring. Okay. So in the first case, it was a mono-substituted benzene ring equals to 5 hydrogen. In this case, it is a di-substituted benzene ring. So what will be the structure? We are having the 5 HIDs. So just you try to detect the structure. One important thing just I want to share with you. So whatever examples we are discussing here, okay, do you know where from I have taken all these examples? Anyone? Any guesses? Any book which you are knowing for the spectroscopy which you are using or for the determinations which you are using? हे कुठून असतील? कुठल्या पुस्तकातले? You will be surprised. You will be surprised that this is not from any Pavia, no. It is from Morrison Boyd, organic chemistry book. You just go for the Morrison Boyd and you check this. This is available in Morrison Boyd. Okay. So thank you very much. Thank you very much, the organizer, Shirke sir. You have given me the opportunity to present in front of all of you. Thank you very much.
Thank you, sir. Thank you. Karishma madam, any questions from your side?
Yes, sir. The first question is, what is the basic difference between FTIR and IR in respective of functional group detection?
Yes. It is very interesting.
By the next slide.
Now see here, we are not having the simple IR instrument. Okay, we are all instrument today available are the FTIR, Fourier transform technique. Okay, so in Fourier transform technique, the intensity of the peak is increased. Okay, so this is done by using the interferometers. Okay, there is a interference produced in the path of radiations that will give the more sharper peaks. So today we are using the interferometers, that is FTIR instruments, rather than we are using the simple absorptive instruments. Old instruments where we are using the simple absorptive process.
The next question, where do we get peaks for NH, NH2? group in IR by
NHNS2.
Dr. Ladda sir.
Yeah, you just see this spectrum for NHNS2. Okay, you'll get a broad peak, okay, which is covering nearer 1700. Okay, so that is NH band, and one more peak is there that you will get near to about 3000. Okay, we get one singlet, doublet, or triplet type of the peak we'll get. So that is for the NH band. So two peaks will be there. So amide groups, they can produce the peak in these two areas. You just see the slide which is given. Single slide will be sufficient to you. Okay, just you take the peak of that single slide, and that will help you to determine the structure of any functional group.
Okay,
Yes.
next question. How to interrupt ortho-meta para positions of benzene ring by Hemlata madam.
Yeah, I can't hear you. What?
How to interpret ortho-meta para position of benzene ring?
Okay, so for this purpose, we had to go towards some finger point region. Okay, so in fingerprint regions at nearer 600 centimeter inverse. Okay, so you get a small peak. Okay, it will not be the sharp peak, so it will be a dented peak. Okay, so if it is a dented peak, so depending upon that shape, okay, so we can confirm. So benzene ring will get only the aromatic ham and the functional group region. So we just now I'm not going in more details of your fingerprint region.
Okay, sir. Next question is coming from Girvani sir. How to interpret cis and trans isomer?
Yeah, cis and trans isomers can also be distinguished. Again, we have to take the help of both fingerprint regions and your functional group region for detection of since these two. Okay, carburation of peak is the first answer for this.
Okay, sir. Last question. How to avoid noise level while performing IR analysis?
Okay, background
Apart from
determination.
drying.
Yeah, it is very interesting. So many times people are not taking the background spectra. As we are not having the double beam instruments, we are having only the single beam instrument. We have to take the background spectra. Okay, either background spectra with air as a reference, or certain polystyrene films are there. We can keep this polystyrene film while taking the background spectra. Many times we are using DRS, and in case of DRS, we can take this background spectra by keeping the potassium chloride, dried potassium chloride in the sample cell, and then we can take the background spectra that will omit the interference. Okay, that will probably omit the interference of this stray light, and you will get the exact means. Again, some instruments are provided with the baseline correction facility, and they can automatically remove this, but determination of background is essential.
Okay, thank you, sir. Over to you, Poonam ma'am.
Now I would like to request our principal, Dr. S.D. Sheke sir, to felicitate our guest speaker, Dr. Devkate sir, with an e-certificate as a token of appreciation.
Yes. So thank you, sir, for this wonderful session. As somebody has written that, I think so, Dr. Ladda sir has mentioned in the chat box that even a person from other specialization could also understand that. So that much in simplified way you have presented it, sir. And even I could also connect being a Sutix person. And I could claim that yes, I will be Atmanirbhar now. But all the time when I am collecting the data and sharing the spectra with Damale sir, then I used to go with to Damale sir and ask him for interpretation. Then he used to interpret and used to calculate everything, and he used to give me the details regarding the compatibility study and all. Now I could claim and I could say that by listening this, I could say that yes, I could interpret and I could be more Atmanirbhar now. Thank you, sir. Thank you. This elaborative session. It was explained in so informative and so simplified way. Thank you, sir. So, as an convener from the BGPS on behalf of Srinath College of Pharmacy, IPA, sir, we present you this certificate of appreciation. Thank you, sir. Thank you for sparing us time. Thank you, sir.
Thank you. Thank you for giving me the opportunity. First time I have given such type of the web seminars. Thank you very much.
Thank you, sir.
So may I give the conclusion remark?
Yes. Proceed, madam.
Thank you, Dr. Devkate sir, for this informative session. Today we have learned that how FTIR is used to quantitatively determine the concentration of molecules and how NMR spectroscopy is used to determine the molecule's chemical structure. Sir has explained very well about the important concepts, similarities, differences, and numericals related to these two powerful analytical techniques in such a simplified way that it will definitely going to be very helpful for all of us. Once again, thank you so much, sir, for this illuminating session. Now, on the behalf of Indian Pharmaceutical Association, Aurangabad branch, management, principal sir, and all the staff of Srinath College of Pharmacy, I would like to thank both the guest speakers of today's session, Dr. Alurkar sir and Dr. Devkate sir, for accepting our invitation, for sparing their valuable time and guiding us with their knowledge and experience. Thank you so much, both of you. And next, I would like to thank all the participants for attending today's session, and thank you for being such an interactive, attentive, and great audience. Thank you all once again. Now, without taking much time, I would like to request Mr. Manoj Damale sir to give further instructions for tomorrow's session. So,
thank you, madam. Very warm good afternoon to one and all. And thank you for your active participation and patiently listening to both the session. So similarly, tomorrow also we have two sessions. The first session is of Dr. Ladda sir. He is going to explain how to do the extraction, isolation of phytochemicals. And followed that particular session, we have a second session of Gattani sir, where he going to discuss about how or what are the application of microbial flora in chronic conditions. The link of both the sessions will be shared in the evening on WhatsApp group. And for today's feedback and attendance, the link of Google form is already been shared on the WhatsApp group. So I kindly request all the participants to please fill their attendance and feedback of today's sessions. So this is all about today's sessions. So here I conclude that all the session of today, day 2, has been over.
Okay, fine.
Thank you all.
Okay.